There, here we have two simultaneous equations, but there's a slight difference. The top equation has x squared and y squared, and if we try to solve this in the usual way by maybe subtracting one equation from another, you'll see that the x squared and the x don't cancel. So we need to find a different way to solve these equations. So the first thing I do is I'm going to take the simpler equation and rearrange it for x. I could rearrange it for y, but that would be a little bit messier because I'd have a sort of a factor of a third here. And I'm going to be substituting that into the x in the first equation. So that gives me 7 minus 3y squared plus y squared equals 5. Now I multiply that out. The 7 squared gives me 49 plus 9 squared, 9y squared. And the cross term is minus 21y, which I double. Next, collect everything onto one side. That gives me 10y squared minus 42y plus 44 equals 0. And I can divide that by 2 just to make things a little bit easier. So I get 5y squared minus 21y plus 22 equals 0. All right, now I'm going to create a bit of space and keep going. So I had last time 5y squared minus 21y plus 22 equals 0. I need to try and factorize this. The 22 is either 22 and 1, or 11 and 2, and the 5 is 5 and 1. And I'm trying to match it up. I notice that 5 times 2 gives me 10, and 11 times 1 gives me 11. So 5y times 2 and y times 11. And since I've got a minus 21 and a plus 22, they're both negative. Just check that works. I've got minus 10y and minus 11y. So the solutions are y equals 11 over 5, which is 2.2, and y equals 2. Now to find the x values, I need to substitute those back into this equation here, or to make it a little bit easier, 7 minus 3y. So the first x value is 7 minus 6.6, which is 0.4, and the second x value is 7 minus 6, which is 1. And that should be the answer.